So today we're gonna finish up chapter 1 and we're gonna cover section 8b today. Today we're gonna be solving rational inequalities, so fractions. So let's go ahead and look at the steps. So when we're solving rational inequalities, again, we need to get the inequality where it's got a 0 either on the left side or the right side. We're gonna combine the terms. So in other words, we're going to be finding a common denominator, and so we're going to combine it so that there's just one fraction. Then, like before when we solved the rational equations, we wanted to get rid of the denominator. This time we're going to keep it because we're going to be setting the numerator equal to 0 and the denominator equal to 0, and then that's going to give us our breaking points on our number line. And then again, we're going to find a test point to plug in, and we're gonna go ahead and figure out the pattern again. The X check. Now, do not try to solve these as a proportion. If you do, you will get them wrong. You always have to move everything over to one side, so that way it's gonna be less than or equal to, greater than or equal to a 0. You need a 0 on either the left or the right side. So let's take a look at our first example. So here we have our rational inequality. We need to get a 0 here. So I need to subtract the 1 and get it over to the left side. So I'm going to subtract 1 from both sides. I now have left with 5 over x plus 4 minus 1 greater than or equal to 0. Now I need to find a common denominator. My common denominator is going to be the x plus 4. So I could add a 1 here, and then notice what this one is missing is x plus 4. So I multiply it to the top and the bottom. Notice the negative sign here. I need to distribute that. So this is really going to become 5 and then minus x minus 4, and I don't want the denominator to go away. I'm leaving it here. And now I'm going to combine my like terms in the numerator. Let me go ahead and move it on up here to the top. So I'm going to combine my 5 and negative 4. So now I'm left with negative x plus 1 over x plus 4. I now set the numerator equal to 0 and the denominator. So now I'm going to go ahead, and if you just want to add the x instead of subtracting 1 and then dividing by negative 1. So the first breaking point on my number line will be x equals 1, and then over here subtract 4 and x equals negative 4. Now what I need to do is put these numbers on the number line, least to greatest, negative 4, positive 1. Again, I always like to see if I could use 0 as a test point. So I can go ahead, and 0 is located right here in the middle. So I'm going to go ahead and plug in 0 into my original problem. So now this is where I need the inequality back. So my original problem was the 5 over x plus 4 greater than or equal to 1. So where I see the x, I'm going to plug in my 0. And then I get 5 over 4 greater than or equal to 1. Well, 5 over 4 is 1.25 or 1 1/4. So this is a true statement. So in the middle here, I'm going to put the check, and then x and x. Now, remember before, whenever we had a greater than or equal to or a less than or equal to, we would always use brackets. The only time I'm going to be using brackets is when the number is going to come from the numerator. Because if I use the denominator, it would make it undefined. So I only put brackets around a solution from the numerator. Everything else is parentheses. So the only thing here that would have gotten a bracket is going to be what I got from the numerator. So this was from the numerator. this equation right here. So in my answer, because it had the greater than or equal to, the 1 is the only one that's going to be surrounded with a bracket. The -4 is going to get a parentheses, because if you think about it, if you plug in -4 here to this denominator, it's going to make this become a 0. So that's why it can't include -4, but it's going to be the starting point. So my interval notation here, it's going to be, and if I had to graph it, it's going to be a parentheses on -4, but a bracket on the 1. So in interval notation, -4, comma 1, the 1 gets a bracket because the -4 came from setting the denominator equal to 0. It will never get a bracket. Now, if your original problem starts with just a simple greater than or a less than, you know everything's parentheses and you don't have to worry about it. So the only time you're concerned about where the bracket goes is when it's a greater than or equal to or a less than or equal to, but it's only going to surround the number that you had set the numerator equal to 0. Remember, when you put these into this interval notation, it has to be listed least to greatest. If you were to put the 1 first and then the -4, it's going to be wrong. All right, so let's go ahead and try the next one. This one's already got the 0 on the right side. So now all I have to do is set the numerator equal to 0 and the denominator equal to 0 to get my breaking points on my number line. So x plus 1 equals 0, x minus 4 equals 0, subtract the 1. I get x equals -1, add the 4. These are going to be the numbers that go on my number line. And again, put them on the number line least to greatest. Again, find your test point. And again, you can pick any point from any interval. I'm going to go ahead and pick 0. So if I plug 0 into the original, I get 0 plus 1 over 0 minus 4. 0 plus 1 is 1. 0 minus 4 is -4. This is a false statement. So in the middle where the 0 was, this is an x. And then the 2 check marks are on the sides. So my graph, again, this is just a greater than. So my graph is going to be a parenthesis going to -infinity and then to infinity. So again, remember this is -infinity, positive, and now your interval notation will be from -infinity up to the -1, all parentheses, and then 4 to infinity. Number 3. So again, we need to move the 4 to the left side. So I'm going to subtract it because again, I need it equal or less than 0 in this case. So now I have 2x minus 1 over 3x plus 4 minus 4 less than 0. Again, if you want to put a 1 here, my common denominator is the 3x plus 4. I'm going to multiply that to both the numerator and the denominator. So now for my numerator, the 2x minus 1 is there, but then now I need to distribute a -4 to the 3x plus 4. The denominator stays the same. And again, I'll put it as an equal 0 because once I combine my like terms, I'm going to set the numerator equal to 0 and then the denominator. So I need to distribute the -4. So I end up with 2x minus 1 minus 12x minus 16. And then I still have that same denominator. I'm going to combine my like terms in the numerator. So the 2x and the -12x, and then the -1 and the -16. So this will give me -10x minus 17 over 3x plus 4. Now set the numerator equal to 0 and the denominator. So -10x minus 17 equals 0. 3x plus 4 equals 0. Add the 17. -10x equals 17. divide by negative 10, and x equals negative 17 over 10. Now remember, we're graphing this. We're putting it on a number line. So you can either change it into negative 1 and 7/10 or negative 1.7, because we need to know where to put it on our number line, least to greatest. Over here, same thing. Subtract the 4, divide by 3, x equals negative 4/3. Again, I'm going to make it a mixed number or a decimal. So it's either negative 1 and 1/3 or negative 1.3 repeating. So now let me set up my number line. So again, I need to put it least to greatest. So the negative 1.7 is here, and the negative 1.3 repeating is here. Notice 0 is located over here on the far right. So when I go to plug in my 0, I get 2 times 0 minus 1, 3 times 0 plus 4, less than 4. 2 times 0 is just 0, so negative 1 on the top. 3 times 0 is 0, so 4 on the bottom. I get negative 1/4 is less than 4. This is a true statement. So this section gets a check. This gets the X. This gets a check. So now my graph, because my original symbol was just a less than, it's going to be here, pointing that way, to the left, and then to the right. Again, remember we got a negative infinity here, the positive infinity here. So in interval notation, will be from negative infinity up to the negative 17 over 10, unioned with negative 4/3 to positive infinity. And they're all parentheses because the original symbol was a less than. So for number 4, we're going to subtract 2 from both sides. And I get 6 over 5 minus 3x minus 2 less than or equal to 0. Again, common denominator. Common denominator is going to be the 5x minus 3. So whatever you multiply to the denominator to make it become a common denominator, do the same thing to the numerator. So now I have 6, and then this is a negative 2 that you have to distribute because it's a subtraction sign to the 5x minus 3. And then it's all over the 5 minus 3x. And now I can make it equal 0 because once I distribute and combine like terms, I'll be setting my numerator equal to 0 and then my denominator. So I'm going to distribute the negative 2. So this ends up giving me 6 minus 10 plus 6x. Still has the same denominator. And now I can combine my like terms here, 6 and negative 10. And this gives me negative 4 plus 6x over 5 minus 3x. Set the numerator equal to 0. Negative 4 plus 6x equals 0. And 5 minus 3x equals 0. I'm going to add the 4x, or just the 4. 6x equals 4. Divide by 6. X equals 4/6, but reduce it to 2/3. For the other one, I'm just going to go ahead and add the 3x instead of subtracting 5 and then dividing. So 5 equals 3x, divide by 3, and x equals 5/3. Remember, 5/3 is going to be 1 and 2/3 when we put it on the number line. So now let me go ahead and draw my number line. The 2/3 is smaller than the 5/3. Notice this time the 0 is located over here on the far left because it's less than 2/3. So then now I'm going to plug in my 0 to the original problem. 6 over 5 minus 3 times 0. 3 times 0 is 0, so I just get 6 over 5. 6 over 5 is 1 1/5, 1 1/5 is less than or equal to 2. This is a true statement. So the area where the 0 is located gets the check. The middle is an X and then a check. So again, the graph, it had a less than or equal to. So remember, the only thing that's going to get a bracket is the solution from the numerator. So this one right here is the only one that's going to get the bracket, the 2/3. The 5/3 is going to get a parentheses. So when I go to do this, this will be a bracket pointing to the left, parenthesis pointing to the right. So negative infinity, comma, 2/3 with a bracket, union with a parenthesis, 5/3 to positive infinity. Now, at first glance, this might be the scenario where you think, oh, I could solve this as a proportion. If you do, you will get it wrong. You need to get a 0 on either the left or the right side. So I'm going to go ahead and subtract the 5/x from both sides. And now I have -5, 3x plus 2 minus 5/x greater than or equal to 0. I need to find a common denominator. This time, my other fraction isn't just a 1. I've actually got 2 pieces here. So my common denominator is going to be both of them. So my new denominator is going to be x times 3x plus 2. So the first fraction is missing the x. The second fraction was missing the 3x plus 2. I need to distribute this -5 to both of these, and then I need to multiply the -5 and the x. So once I distribute that -5, I get -15x minus 10. And now I'm going to go ahead and put the equal 0, because I got to combine my like terms in the numerator. Now the denominator, you don't need to distribute that, because remember, we're going to end up going back and factoring it anyways. So always leave the denominator alone, but the numerator always has to be distributed and the like terms need to be combined. So here my like terms are just the x's. So in the numerator, I'm going to get -20x minus 10, and then the denominator I'm leaving alone, because now I need to set the numerator equal to 0 and the denominator equal to 0. By not distributing the denominator, this is already going to go to my answer, because I'm going to set x equal to 0 and then 3x plus 2, the two factors. I can go ahead and do this one, then I'll go back and do the numerator. 3x equals -2, divide by 3, and x equals -2/3. Now for this one, add the 10. -20x equals 10, divide by -20, and x equals -1/2. So now I have 3 breaking points, so it's going to make 4 sections. So let me go ahead and put it on the number line. So I have -2/3, -1/2, and 0. Notice I can't use 0 as my test point because it's one of my answers. So I'm going to plug in a 1. So if I go back to the beginning and grab my original problem, I get -5 over 3 times 1 plus 2 greater than or equal to 5 over 1. -5 over 5 greater than or equal to 5. -5 divided by 5 gives me -1. -1 is not greater than or equal to 5. This is a false statement. So where 1 is located, this is an X, a check, an X, a check, and now my graph. And again, notice it's a greater than or equal to, so I need to see which number came from my numerator because that's going to get the bracket. So here, the only thing that came from the numerator was the 1/2. So this one's going to get the bracket. The 0 gets the parenthesis. And then here also a parenthesis because those two came from the denominator. So now my interval notation is going to be from negative infinity up to the negative 2/3, parentheses, union, bracket, negative 1/2 to 0. And for the next one, do not solve it as a proportion. We need to get 0 on either the left or the right side. So I'm going to go ahead and subtract the 3 over 2x plus 1 and get it on the other side. And now I have 1 minus x minus 3 minus 3 over 2x plus 1 less than or equal to 0. My common denominator is going to be both the x minus 3 and the 2x plus 1. So the first fraction is missing the 2x plus 1. And 1 times 2x plus 1 is just going to give me 2x plus 1. Over here, this one's missing the x minus 3. Notice I need to distribute this as a negative 3. So this becomes negative 3x plus 9. I now need to combine my like terms in the numerator, leave the denominator factored. So I end up in the numerator with negative x plus 10. We're leaving the denominator alone because again, remember, we're going to just have to go back and factor it anyways. So then the numerator, negative x plus 10 equals 0. The denominator, I'm going to set x minus 3 equals 0 and 2x plus 1 equal to 0. This one I can add the x. I get x equals 10. This one I'll add 3. X equals 3. Subtract 1. Divide by 2. And x equals negative 1/2. Now remember, the original symbol was less than or equal to. And remember, the only thing that I got from the numerator was the negative x plus 10. So x equals 10. We'll get a bracket. The other two are going to get parentheses because they came from the denominator. So let me make my number line. And I'll put them on least to greatest. So the negative 1/2 first, then the 3, then the 10. This time I can use 0 as a test point. It's located right here. So when I plug it into the original, 1 over 0 minus 3, less than or equal to 3 times 2 times 0 plus 1, 1 over negative 3, 3 over 1. So negative 1/3 less than or equal to 3. This is a true statement. So right here where my 0 goes is a check, x, x, check. So again, the 10 gets the bracket going this way, and then these are parentheses. So my interval notation, negative 1/2 comma 3, surrounded in parentheses, union with a bracket around 10, going to infinity. For the last one, again, get a 0 here on the right side by subtracting 3. So 2x minus 7 over x minus 5 minus 3 less than or equal to 0. Common denominator, it's going to be the x minus 5. So for the denominator, just write the x minus 5. For the numerator, I have to distribute this negative 3 to the x and to the -5. I can combine my like terms. 2x minus 3x is -x. -7 plus 15 gives me +8. I'm gonna set the numerator equal to 0 and the denominator. I'm gonna just add the x. I get 8 equals x. Add the 5, x equals 5. Add these two numbers onto my number line, least to greatest. So the 5 and then the 8. My test point again is going to be 0 because it wasn't one of my answers. 0 is located here on the far left. So when I plug it into the original, I get 2 times 0 minus 7. 0 minus 5, less than or equal to 3. 2 times 0 is 0, so the numerator is just -7, denominator -5. This will simplify to +7/5. 7/5 is 1 2/5. 1 2/5 is less than 3, so this gets a check. X, check. And again, what came from the numerator was the 8, so this will get a bracket. This came from the denominator, it's going to get a parenthesis. So here, again, it's got the -infinity and the infinity. So from -infinity up to the 5 with a parenthesis, because it came from the denominator, 8 gets the bracket to infinity. And again, graphing it, parenthesis pointing to the left, bracket pointing to the right. So on WebAssign, watch your grouping symbols. You know, if it gets marked wrong, maybe it was a wrong grouping symbol. So just take your time. If you use the equation editor, you can use the infinity symbol. If you're not using the equation editor, you're typing in the word infinity. And that is it for the notes on 1.8b, and that is the end of chapter 1.